Okay, someone asked me to do question 7 here on the physics paper. So let's have a look at that. A hammer is thrown in an athletics event where athletes rotate a metal. Okay, it's this event here. Derive the formula to show the relationship between the radius, the velocity, and the angular velocity an object moving in uniform circle. Oh, so they want the proofs of the formula. Derive the formula to show the relationship between the radius, the velocity, and the angular velocity. So that's the formula, I think, that goes V equals or omega. It's that formula there, the radius, the velocity, and the angular momentum. So the way I would do that proof now, oh, it's been a long time since I've done it, but I think what I would say, um, this here is the arc, that's the theta, and that's the radius. So in radians, by definition, the arc length is equal to r times theta. If you differentiate that, you get dl dt equals, the r is constant, d theta dt, but that by definition is omega, and that by definition, the rate of change of distance is speed, or velocity if you include a direction. So yeah, that's it. Explain what is meant by centripetal force. This is the force acting towards the center. Oh, centripetal force. I gotta be careful here because there's a subtle difference between centripetal force and centrifugal force. So yeah, centripetal one is the one directed towards the center. So when a body is moving in a circle, it is due to a force acting on the body, directed to the center of the circle and perpendicular to the velocity. This is known as the centripetal force. Okay. Yeah, okay. Let's have a look at part 3 now. Draw the force diagram to show the forces acting on the ball just before it's released. Okay, there is a tension in the ball, and there is a weight acting on the ball. An athlete rotates a 4 kilogram in a circle of 1.25. The ball is moving at angular velocity 21.6 just before it's released. Calculate the centripetal force on the ball. Okay, so that calculate the centripetal force. Yeah, which is the T, which is the F, which is the MA, which is the M omega squared, or which is 4, 21.6 squared, 1.25. That is 2330 newtons if I'm doing 3 significant figures. And this is towards the center. 5, calculate the magnitude of the velocity of the ball just as it is released. Yeah, that formula, that's V equals omega r, I suppose, right? Yeah. So that would be 21.6 times 1.25. So that is 27.0 meters per second. The velocity of the ball as it is released is at an angle of 36 degrees above the horizontal. The ball is released at a height of 1.26 above the ground and lands at 3.79 seconds later. Okay, so here's the ground. The velocity of the ball as it's released at an angle of 36 degrees above the ground, above the horizontal. The ball is released at a height of 1.26 above the ground. So that 27.0 meters per second, that has a horizontal and a vertical component. So the horizontal, that's 27.0 cos 36 degrees. That's 21.8 meters per second. And the vertical, that's 27.0 sine 36. That's 15.9 meters per second. Ignoring air resistance, calculate the maximum height above the ground reached by the ball. So if you just look at the vertical, the U is 15.9, the V is 0, the A is minus 9.8, the T we don't know, and the S is what we want. So if we use the formula, V squared equals U squared plus 2AS, I can solve this for S. That is 12.9, but then I have to add on the height off the ground here, 1.26. So that is 14.1 meters. Okay. Calculate the horizontal distance traveled by the ball in 3.79 seconds. So horizontally, that's just speed multiplied by time. So that is the 27 cos 36 times, what is it, 3.79? That is 82.8 meters for part B. And finally, how would air resistance affect the path of the ball? The range is reduced, and the max height is reduced. Yeah, okay. I did this pretty quickly. Hopefully there's no mistakes in it, but if there is, just post in the comments.